Hi, I'm Donald McIntyre, Senior Editor at the ETC Cooperative. This is the ETC Proof of Work course, Class 5, the Proof of Work Mining Difficulty Adjustment Explained. In the previous Class 4, we explained the broader Nakamoto Consensus design, each of its steps and its features and benefits. One of the most controversial parts of the Proof of Work POW method is the difficulty adjustment system. Nick Szabo expressed concerns about it as it is a manipulable parameter, just like the monetary policy of proof of work coins, and not a completely objective and work-based way of regulating the supply of the digital asset as is BitGold. On the other hand, Saifedean Ammous, the author of the Bitcoin Standard, the Fiat Standard, and Principles of Economics, praised the difficulty adjustment as one of the most important components of Nakamoto Consensus because it regulates the supply of the cryptocurrency. In this post, we will explain how the proof of work difficulty adjustment works and what are its benefits. What is the difficulty adjustment? The difficulty adjustment basically regulates the timing of the supply of coins in proof of work blockchains as it enlarges or reduces the target to hit to determine the cryptographic stamp per block so that blocks can be created more or less constantly at the stipulated time intervals in each network, thus printing the coins at a steady pace. For example, the difficulty adjustment keeps Bitcoin's block creation at 10-minute intervals on average, ETC at 13 seconds, and Litecoin at 2.5 minutes. This ensures that the printing of the coins is not too fast or too slow when miners increase or decrease hash rate in each network due to market conditions. How does the difficulty adjustment work? As miners need to hit a target range of numbers when creating the cryptographic stamp per block, the target can be enlarged or reduced depending on the speed of the blocks. The speed of the blocks increases or decreases if the total computing power held by miners increases or decreases. In the next sections, we will explain states and options of the difficulty adjustment system. 1. Stable difficulty state. In a stable difficulty state, miners will take, on average, a certain time to hit the target for each block. In these conditions, the time is 10 minutes per block in Bitcoin, 13 seconds in ETC, and 2.5 minutes for Litecoin. Note in the diagram that in the stable difficulty state, it takes a number of attempts, red crosses mean failed attempts, to hit the target. The green cross is the one that hit the target. 2. Reducing difficulty. If, for example, miners reduce the hashing power because the coin market is down, then the time that it would take to find a block would increase, slowing the creation of coins. To solve this and adjust the time back to the desired average, the target range will be enlarged, making it less difficult to hit. Note, as indicated in the diagram in this section, that less difficulty takes less attempts to hit the target. 3. Increasing difficulty. If miners were to increase the hashing power because the coin market is up, then the time that would take to find the block would decrease, creating more coins faster. To solve this and adjust the time back to the desired average, the target range will be reduced, making it more difficult to hit. Note, as indicated in the diagram in this section, that more difficulty takes more attempts to hit the target. So this is, say that we start here and the network is stable, ETC for example is stable, creating blocks every 13 seconds, which is the target. So then the difficulty is going to stay stable here, and miners in every round, they're going to take X amount of, a certain number of attempts to hit the target. So they attempt many times until finally one hits the target, which is this green one. If for some reason there's less hashing power because the market is down or some other economic condition, then the blocks are going to get, they're going to be 15 seconds, 20 seconds, 30 seconds, they're going to get longer as less computing power, less miners are in the network. So in this case, the difficulty, you see here that the difficulty is reduced because now the target is bigger. To hit the target here, the black area is bigger. So in general, because there's less miners or less mining power, it's going to take less attempts to hit the target. And the opposite happens when there's more hashing power. When there's more hashing power, then the blocks are going to start being created at 12 seconds, 10 seconds, 8 seconds, 5 seconds, very fast. So to regulate that, the difficulty adjustment, it reduces the target. You see here the black part is reduced. So now the miners, because there's more miners or more machines or more hashing power, they're going to take many more attempts. So they're going to go back to 13 seconds. And one of them is going to hit here, the small one, this small target, every 13 seconds, because now they're taking more time, more effort or more work. Benefits of the difficulty adjustment in proof-of-work blockchains. The difficulty adjustment in Bitcoin avoided the problems that Satoshi had when he created it. There was no market inside the network to exchange the bit gold for coins, and there was no technology available yet to create these tokens backed by bit gold. The difficulty adjustment simplified the mechanism by just creating coins in exchange for the work of the miners. But the bit gold itself was not used and has been buried in proof-of-work blockchains ever since. The end result is that the difficulty adjustment regulates supply of these coins by regulating block times, therefore stabilizing the blockchains in terms of their monetary policies, hash rates, transaction velocities, confirmation times, settlement times, etc. Putting it all together for Ethereum Classic. From classes 1 through 5 of this course, we have explained how proof of work works in detail. The benefits of proof of work to ETC are decentralization, permissionlessness, hard money, and censorship resistance. In the next class, we will explain the benefits and the great advantages of ETC with regards to Bitcoin and Ethereum. Thank you for watching this video. ETC Proof of Work course, Class 5, the Proof of Work Mining Difficulty Adjustment explained. To learn more about Ethereum Classic, please go to ethereumclassic.org. Thank you very much.